Hi everyone, welcome back to my channel. Okay, so let's just recap quickly what we've done so far. So we've basically created a sketch using Python and connecting to Inventor API, basically using Python. So let's just run this code and see what happens. So if you want to know what happened up to here, you can watch the previous videos. So it's taking a bit of time. So I think Inventor is just waking up. Yeah, so it created a little part document, and then it's also created the sketch. So previously we created a center point rectangle, the sketch based out of center point rectangle, and we made the origin as 0 0, x is 0, y is 0, and then we wanted the extents of the center point rectangle to be 60 millimeters, apologies, 80 millimeters, and 30 in height. So from here to the extent is 80, and from here to here is 30. So if we measure that, measure this quickly using the measure tool. Yeah, so we get 60 from here to here, and from here to here we would get 30. Okay, so now what we need to do is basically we need to extrude this document. So another thing is like usually when sorry, I must have deleted display mistake. So yeah, usually when we create a sketch, what it does is, what Inventor keeps doing is it gives us in this view. So basically, we are able to we would like to look at it in a not in either um, an isometric view like this, so which is easier for us to see when something gets extruded. Otherwise, if it is just in the front view, probably you don't see the transition of the sketch going from um, a sketch to a solid model. So in order to do that, there is a little snippet of code which I would like to explain here, and that would be basically, we need to set it to home. So what we would normally do in Inventor is, let's say the sketch is in the front view, we would click on the home button, right, in order to ask it to go home, go to the home position. So in order to do that, what we would do is, like, we would go to the we will access the Inventor application object, and then we need to select the active view. So this is the current view, so active view, and then active view has a method called go home. So all this can be found in the Inventor API object model and the Inventor API help, so we can look through. Like, for example, if you want to find out what is this go home, obviously you can go and click on the help here, or even better, click on help, programming API help, and you can just come here and type in the actual method name, go home. So we know that it creates basically method that sets the view to the default view of the model, which is the home view. Okay, so now we've done that, so let's crack on with creating the actual extrusion. So what we're going to do is create an extrusion. Okay, so now again, we used to have something called as uh, the part component definition, which was explained earlier. So part component definition is basically, it's a collection object, and it's everything that's within the model space, basically. So we added a sketch to it. Now we need to let Inventor know that this is the profile that we're going to be extruding. So let's set the uh, profile over here. So let's create a variable called solid profile, and set it to the sketch. We already have the sketch object here, which we created, which is this sketch, which composes of all the information regarding which plane we're going to be drawing, and also the information about the profile as well. So we're going to type in sketch, and sketch has a collection object called profiles, and profiles has a method called add or solid. Also, please note that in while using Python, you have to have these like brackets in here, these close brackets, the open and close brackets over here, for any method that you're using. So if you don't add these close brackets, what it'll do is it'll give us another error, right? So now we've created this profile. So let me just close this part here, and let's try to rerun the code, see what happens. So as you can see now, the orientation is based in the default orientation, and it's not like a front view or right view or top view. Instead is the orientation which is isometric at the moment, and that's because we've mentioned it to do it here. We've kind of like requested the Python code to give us the isometric view, and now we've created a profile for us to extrude. So at the moment it's not showing up here, but you'll see how this develops into an actual solid part. So now we are going to create the actual extrusion feature. So creating the feature. This is basically creating the feature in the feature tree, right? So how would you do that? So again, we'll have to call the part component definition because we're working within the part component space. And part component definition has a collection called features, which stores all the features within it, like extrusion or extrusion cut or a fillet or anything like that. And within features, what we're looking for is extrude features. Features and extrude features should have a method called create extrude definition. So again, let's go inside here and search for extrude features object. And as you can see, it gives us the two methods, add and extrude, create extrude definition. So extrude definition basically is a method that creates a new extrude definition object. The object created does not represent an extruded feature, but instead it's a representation of the information that defines an extrude feature. So you can use this object as input to the extrude features.add method to create the actual feature. So that's kind of like self-explanatory what it does. So basically it doesn't actually extrude itself, but it actually packs all the information for us to extrude in the future. So we can use this information to go and extrude in the future. So now, as it was explained earlier, so we can use the add method now. Add method. Oh no, sorry. Yeah, we can't add method yet. Sorry. So um, let me just go check that again. So we are using the create extrude definition method. So extrude features dot create extrude definition method. I think I did not copy that. Let me copy it again, and then create extrude definition. So within create extrude definition method, we define the profile, and then the operation we have to define. So operation is basically if you want to extrude it in one direction or the other direction, in the positive direction or the negative direction, or in both directions. So that's what part feature operation enum is. So profile is what we already defined here, which is the solid profile. So here we would just type in solid profile, and now we have to define the direction. So we have to define the operation. So let's go inside. Let's take uh, the join operation. So what is a join operation? Join operation is basically just it just like how does it? So basically, it connects all the loops together. This is what I think it is. So it connects all the loop together. So it just so anything within this space will be extruded rather than like a surface. This is because it's a small solid model, so it will just join everything, and the whole enclosed profile will be extruded. So that is the that's what I would like to do. So as you can see, it's a cut operation. So is it going to remove material, or is it intersecting, or are we creating a new body or a new surface? So we would like to create a new extrude. So hence, we're using the join operation here. Okay. So part feature operation enum is basically joining the profile, right? And then So we've done that. So we've taken this and used this number join operation 20481. Yes, we've added that information. So now we would need, okay, so now we basically need to define the direction in which it's going to extrude, right? So we've defined the profile and everything, but we need to know what direction is it going to extrude. So in order to do that, let's assign the return value of this expression in line 33 to a variable called extrude solid, right? Extrude solid. If I can spell it properly. Definition, yeah, extrude solid definition. That's what we'll call it for now. Okay, so now we need to set the distance basically of how much we're gonna extend it by. So we're gonna take this extrude solid definition, and then we're gonna basically there is a method called set distance extent, right? So set distance is a method. So this is for corner chamfer, so we're not looking for chamfer. So set distance extent is what we're looking for. So we need to define the extent, and then we need to define the part feature extent direction. So we would go negative in this one. So we'll take that, we'll copy that. So we go to set distance extent, distance as a variant. So we have to define the distance here. So now, uh, as we all know, if you want like to extrude it by 10 millimeters, you have to divide it by 10 and drop it in as 1 centimeter, because um, here by default everything is like whatever number you type in will be taken as centimeter by default. So if you want 10 millimeters, obviously it's 1 centimeter. And then again, the extend direction, we're going to go in the negative direction, so negative extend. So that's what 20994 is what we're going to be using. Now that's defined. Now we have to add this information to the part component definition. So we have to let the features know that this is the profile that we need to be added into the model view tree. So how do we do that? So now let's call part component definition. Again, we call features collection. So we need to add it to the features collection now. And as before, we knew that features has extrude features. Extrude features. So features as another collection called extrude features. All this is within the Inventor API. And as we saw earlier, so it has an add method. So we're going to add now this whatever we've extruded. So now the profile is kind of like all the information required to extrude the profile is packed in ext underscore solid definition. So that's what we're gonna use here. Apologies, let me copy this. Now we should be able to extrude it. Before that, let me just quickly explain this piece of code. So if you see features, extrude features, add. So how do we know this? Like if you go into, can I just find, yeah. So if you go into part document features. No, I'm not looking for sheet metal features. I'm looking for part features, no I features. Let me see. Yeah, part features. So part features is a collection object which exists inside the part component definition again. So application documents, then within documents has part document. So within part document we have part component definition. Like okay. And then within part component definition, we have part features. Hence, the naming convention features. We don't necessarily have to keep saying part features, but that's just there for us to reference. Whereas when the API document, like the object model document, says part features, we just have to know that that is a collection called features within it. And within the part feature, we have chamfer feature, we have all sorts of different features. But what we are looking specifically is for the extrude features. So let's see if there is an extrude feature. There should be one. So it's all named alphabetically as well. So yeah, extend extrude features. So extrude features is another collection object. So within extrude features, we are looking for the add method, right? So we're looking for the add method. How do we know this? So we go back into our help API. Uh, okay, let's go extrude features. Extrude features. So we're looking for a collection object. So this is good feature object, but we need features. Yeah, extrude features object. So which has got add method in there. So extrude features has got add method. So inside the add method, we actually uh, pass in the argument, which is the extrude definition, which we already created here. So now when we do that, hopefully we should get a feature which is extruded. Let's try that now. Let's close this. Let's rerun this program. And there you go. You have the sketch and it is extruded to 10 millimeters. Let's measure this. So yeah, there you go. And hopefully you like this video. Please feel free to comment and like and subscribe. And if you want me to make any more tutorials on any other thing that you want me to do using Inventor or Python, or even how to connect Excel to Python, or using VBA, iLogic, anything like that, please do comment below. And yeah, so I'm very new to making these videos. So I thought this type of content is kind of lacking on the YouTube space, especially for Python and Inventor. My goal is to like expose you guys to Python a little bit over here and show you how to like automate parts using Python and Inventor, and eventually move on to machine learning and show you how we can use Python to leverage machine learning and also some CAD side of things as well. Hopefully, you guys will benefit from it. If not, please do recommend what type of content you would like me to add, or if there any improvement that I need to make. Thank you very much, and I'll see you in the next video.